Hello, students. We need to talk about naming alkenes. So remember, alkenes are hydrocarbons that have at least one double bond. So taking a look at number 1 here, the first rule says find the longest continuous carbon chain that includes both carbons of the double bond. So if we look at this molecule right here, you can see that the pink labeling here is telling you that you're going to consider this to be the parent chain right there. Now, that's because that's the longest continuous carbon chain. So, the carbon chain where you can count the most carbons without picking up your pencil, and that includes the double bond. So, what we have is we have 1, 2, 3, 4, 5 there. Now, you have another continuous carbon chain that's longer, and you can see it in green over here. So we would do 1, 2, 3, 4, 5, 6. But that 6 carbon continuous chain does not include both carbons of the double bond. So again, you have to have both carbons of the double bond. That's very important here. Now notice how we numbered backwards on the molecule to the left. And that's because, as IUPAC tends to do, it wants you to keep the numbers as low as possible. So we want the double bond to be between carbons 1 and 2 and not between carbons 4 and 5. So that's why we went backwards in our numbering. Now, this is a 5 carbon continuous chain, and you can see right here that it is named with the ENE ending that indicates there's a double bond in there somewhere, okay, that it's an alkene. So that brings us to rule number 2 that says go ahead and name this the longest continuous carbon chain that includes both carbons of the double bond as the parent chain by changing the ending from "ane" to "ene. So somehow the formatting got messed up when I saved this as a PDF, but that's okay, we'll roll with it. So pentane turns into pentene, and that's what we have here. Okay, pentane goes to pentene, and not Pantene because that is 2-in-1 shampoo. Ew. Okay. So number 2B, the second bullet there, says if there are 2 possibilities, you want to choose the principal chain to be the one with the greatest number of double bonds. So that means if you have a choice between your longest continuous chain that has 1 double bond or one that has 2, you would choose the option that has 2 if there's a choice. Now notice how there is a branch up here that comes off of our longest continuous carbon chain, and we would number and name that as usual. So it has 2 carbons there. So that's going to be which branch? That's going to be an ethyl. And it's off of carbon number 2, so of course we would stick a 2 in front of ethyl, and then we would stick 2-ethyl in front of pentene. So we would have a 2-ethyl pentene, but that's still not quite correct. We need to indicate where in the chain the double bond is, and that brings us to rule number 3. So that says number the chains so the double bond has the lowest number possible. We already talked about that. And place that number before the parent chain. Okay, so looking at the chain that is below point number 3 there, we can see that it is a 6-carbon chain because it's already numbered in pink there, and that the double bond is between carbons 1 and 2, and we want to locate where that double bond is, and so we say 1-hexene. Now, if it starts at carbon 1, it has to end at carbon 2. So we don't put 1,2-hexene there. We just put 1-hexene. And then we assume people know that if it starts at carbon 1, it'll end at carbon 2. So yes, that one is 1-hexene. Now using this rule right here, let's go ahead and put the name for this one all together and we'll put it down here. So that would make it 2-ethyl and then what? And then hyphen 1-pentene. You will also see it written as 2-ethyl pent 1-ene. That's like the new way to do it that IUPAC says is even more precise because the 1 is by the ene, and then you know that the 1 definitely goes with the location of that double bond. And the rest of us are like, that looks a lot stranger than it even already is because you're putting a 1 in the middle of a word, and that's weird. Yes, I understand. So most people still go with this one, but just know if you see that one right there that it's not wrong, it's just the new way. Because those people, don't have anything better to do than make new rules for naming, which, gives me job security, and then I have something to teach you. All right, going on to the next page. Oh, we have 2 number 3s. That's really interesting. Oh, well, okay, we'll roll with it. So the second number 3 says you want to identify the substituents with number and name. So we've already done that one because we did 2-ethyl, 1-pentene, but let's go ahead and practice that again. So we have identify the substituents. So what's this one up here without peeking down there? Yeah, that's a methyl group. And we numbered our chain forward. Okay, so 1, 2, 3, 4, 5, 6. What would have happened if we numbered it 1, 2, 3, 4, 5, 6? Well, if we would have numbered it backwards, our double bond would still be between carbons 3 and 4 right there. So that wouldn't be messing with that. But IUPAC says whenever possible, keep your numbers low. So if we numbered it backwards, that would still give us a 3-hexene, but that would change the methyl to what? It would have changed the methyl to a 5-methyl. So that's why we numbered it forward, because you would prefer to have a 2-methyl rather than a 5-methyl. But remember, the low numbering takes precedence for the alkene. So that one had to come first, but on this particular molecule, it didn't matter. So what we had is we have a 2-methyl. So we've got a methyl group on carbon 2, and then 3-hexene. So the ene is telling us we've got a double bond. Where is it? Well, it starts on carbon 3 and it goes to carbon 4. So that's what that name is telling us. Oh, and the hex is telling you you've got 6 carbons total. Alrighty, moving on to number 4. If there are more than one double bond in your parent chain, identify each double bond's position by number and indicate how many are present using Greek prefixes. So if we have 2 double bonds, you would expect us to say diene. If we have 3 double bonds, you would expect us to say what? Probably triene, and then if we had 4, tetraene, etc. But IUPAC says, ha 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 ha, that would make sense. But what we want you to do is we want you to put an A before those names and make it a diene and a triene. Where the A comes from, well, it just flies in from outer space and it puts itself right there before your Greek prefix. So you see it right there and right there. And IUPAC says because that's easier to say it that way. So there you go. Those are the rules. I'm sorry, folks, but those are the rules. All right. So the first one on the bottom there to the left, if we try numbering forwards, we have 1, 2, 3, 4, 5, 6. So that means that we would have a double bond starting at 1 and ending at 2. So we'd have a 1 and then starting at 5 and ending at 6. So we'd have a 1, 5. If we numbered backwards, we'd have a double bond starting at 1 and ending at 2, and a double bond starting at 5 and ending at 6. So we'd have a 1, 5 either way, and we don't have any branches hanging off of this chain to tell us which way we should go. So you can go either way. So what we would say is, okay, we have a 6-membered longest continuous chain. So we have our hex here, and it has 2 double bonds. So we want diene, and IUPAC says, ha ha ha, you have to throw an A in there. So we have hexadiene. Well, because we said that we have 2 double bonds, we have to locate them. Where are they in this chain? Well, the first one is between carbons 1 and 2, and the second one is between carbons 5 and 6. And remember, you just have to number the first carbon of the double bond because double bonds have to be between consecutive numbers. So between 1 and 2, or 3 and 4, or 5 and 6. They cannot be between non-consecutive numbers like 1 and 6 or 1 and 4. It doesn't work that way. The other way that you might see this is you might see it written hexa 1, 5 diene. Why? Because IUPAC. Sorry, folks. So if you see it like that, again, it's not wrong. It's just the newfangled way. But yeah, that looks weird to pretty much everybody except for IUPAC. Okay. All right. So looking at the one to the right over here, let's look at this one. So what we have a choice of here is numbering forwards or backwards. And you can see that it's numbered forwards for you. What would happen if we numbered it backwards? Well, we would have double bonds, which remember take precedence in numbering over our branches. Okay, in alkenes, all we had to worry about were the branches, but here it's where the double bonds and where the branches, and the double bonds take precedence for the low numbering. So here we have double bonds between 1 and 3, whichever direction you go, but you have a methyl branch right there. Now, if you number forwards, left to right, where it's pink, you would have your methyl on carbon number 2. If you number backwards, the blue numbering, what you have is you have a methyl on carbon 3. And IUPAC says you want to keep the numbering as low as possible. So you start out naming it as usual. You've got your branch. Where is it? It's on carbon 2 of this chain. And you have a 4-carbon continuous chain with 2 double bonds. Where are those 2 double bonds? Well, one of them starts at carbon 1 and the other one starts at carbon 3. And remember, IUPAC says throw an A in there in front of the Greek prefix because butadiene is easier to say than butadiene, which I can see what they're saying right now. That kind of makes sense. All right, so 2-methyl-1,3-butadiene. Alrighty, folks, let's do some problems here. We want to name the following alkenes. Alrighty, so on this one, on the top left, we can number left to right, or we can number right to left. So with alkenes, we would have looked at the methyl groups first and said, oh, aha, that first methyl group, we can put it on carbon number 2. Whereas if we went left to right, the blue numbering, the first methyl would be on carbon number 5. But remember, with alkenes, your double bond takes precedence in the numbering. So we want to take a look at that double bond. Now, with the blue or red numbering, which one allows the double bond to have the lower number? Well, that would be the red. Oops, I've got it on erase there. So that would be the red, numbering right to left there. We would have our double bond starting at carbon number 3. Whereas if we do the blue numbering, we would have the double bond starting at carbon number 4. So IUPAC says we have to go with the red numbering. So what we have here is we have a 3, and what is 7? 7 is hept. So instead of heptane, we have heptene. So that is our parent right there. So I'm just writing down my thought process here. And now my branches. I've got a 2-methyl, and I've got a what? I've got a 5-methyl. So I'm going to go ahead and put these together and write them up here. And now we always start with the branches. So we've got 2 methyl groups, and we need to locate both of them. So we're going to say we've got a methyl group on 2, and we've got a methyl group on 5. So again, folks, you've got 2 methyls. Where are they? One of them's on 2, the other one's on 5. If you've got 2 of them, you have to locate both of them, friends. Okay, so we've got 2,5-dimethyl, and then our parent is 3-heptene. So between letters and numbers, we have hyphens. So we have -3-heptene. 2,5-dimethyl-3-heptene. And if you want to do it new IUPAC, you'd have hept3-ene. And again, they want to put that 3 right next to the ene, so you can definitely tell that that double bond is beginning on carbon number 3. So it's between carbons 3 and 4. Okay, folks, moving on to the molecule to the right over here. All right, so we want to look for our longest continuous carbon chain, and it's got 2 double bonds there. So IUPAC says we want to include both of those. So we can do 1, 2, 3, 4, 5, 6. Or we can do 1, 2, 3, 4, 5, 6. And if we take a look at the blue numbering, you can see that you've got a double bond starting at carbon 1 and a double bond starting at carbon 4. So you have a 1, 4. Whereas with the red numbering, you have a 2, 5. So you have your double bond starting at 2 and a double bond starting at 5. So you're going to want which color, your blue or your red? You're going to want your blue because 1, 4 is lower than 2, 5. So that's what we're going with And it might seem like I ignored the branch because I did, because IUPAC says that the numbering of the double bonds takes precedence over the numbering of the branches. Alrighty, friends. So, what is my parent here? So, my parent is going to be some kind of hexene. So there's 6 carbons. In an alkane, it would be hexane, but there's double bonds, so it's hexene. And where are they located? Well, we start at carbon 1 and go to carbon 2, but remember we don't need to put 2 there, we just need to put where it starts. So 1, 4, and then we'll have hex, and instead of just putting hexene, we need to say there are 2 of them. And IUPAC says if you have a Greek prefix, then you need to throw an A in there to make it easier to say. So we have hexadiene, okay? So we have 2 double bonds. Where are they? They are on carbons 1 and 4. So they're between carbons 1 and 2 and 4 and 5. So our branch, my friends, what is this branch right here? It's got 3 carbons, and we're connecting to one of the end carbons, also called a terminal carbon. It's on the end. That is a regular old propyl. Okay, if it was isopropyl, it would be connecting to the center carbon, which it is not. So we have a 3-propyl there. And I am going to go on up to the top to give us a little more room to write this. So taking it up here, what we have is we have a 3-propyl, 1,4 hexadiene. That's what that one is called. 3-propyl, 1,4 hexadiene, or 3-propyl hexa-1,4-diene. But who wants to put numbers in the middle of a word? Not me, only IUPAC. All right, let's go down the bottom and do some cyclic structures, because those are always super fun. All right, so taking a look at this one right here. So again, we want to keep that double bond having the lowest number possible. So we're going to start the double bond on number what? On number 1, of course. All right, so we have 1, and then you have the choice of whether to put 2 up here or 2 down there. Now, which way do you think you should go? Down, that's correct, because a double bond, remember, needs to be between 2 consecutive carbons. So between 1 and 2 or 2 and 3. It can't be between 1 and 6. If we were to number counterclockwise, what you would see is that double bond is between carbons 1 and 6, and that is a big fat no-no. You will get a big unhappy face on your paper if you do that in Professor Gray's class. Okay, so let's back up. And we're going to erase that right there. Now let's just continue to number all the way around so we can see how many carbons we have in our ring. Okay, good, we have 6. So let's take a look at what our parent chain would be called. So we're going to go ahead and say, all right, we've got a double bond there, so I need to locate that, and I'll say that we've got a double bond between carbons 1 and 2, which I just label with a 1. And that's going to be cyclo. And don't forget the cyclo, that's a common student mistake. Cyclo, and what is 6 carbons called? That's called hex. And if we had a 6-carbon cyclic molecule that did not have a double bond, it would be cyclohexane. So this one is called what? Yeah, that's right, cyclohexene. And our branches, we have a 1 what? Methyl, and we have a 2 methyl. Okay, so that's gonna give us 1, 2 what? Dimethyl. You are correct. 1, 2 dimethyl, 1 cyclohexene. Okay, now here is something that you will see quite often. You will often see that there is no 1 there in front of the cyclohexene. Now, why? Well, if there is only 1 double bond in a cyclic structure, that double bond has to start on carbon number 1. Why? Because you want to keep it at the lowest number possible, and you get to number the cyclic structure. And IUPAC says keep that thing at the lowest number possible, and the lowest number possible is what? 1, because you don't have a 0 carbon. So you will also see 1, 2 dimethyl cyclohexene, and this is saying you've got a double bond in a 6-membered cyclic structure, and there's no number there, so it must start at carbon number 1. If it was somewhere else because of some other reason, it would have a number, but we don't have that situation, so that's what we have, okay? So 1, 2 dimethyl cyclohexene. Okie dokie, Smokies. Moving on to the structure that we haven't done over here, and let's do green. All right, so if we were just doing a regular cycloalkane, we'd probably want to start number 1 right there, because then we would be giving our branches the lowest number possible. But IUPAC says, your double bond takes precedence. So we have a couple of choices. We can go 1, 2, 3, 4, like that. Or we can do 1, 2, 3, 4, 5, 6, like that, because we're going to start our double bond on carbon number 1, because we have to keep the double bond at the lowest number possible. And with a cyclic structure, you get to start the numbering where it goes, okay? And the double bond has to be between 2 consecutive carbons. So it has to be between carbons 1 and 2. Remember, don't put it between carbons 1 and 6 or 1 and 7 or whatever else, all right? So in both of our choices here that we've done, we've put the double bond between carbons number 1 and 2, okay? Now, we have the choice between 4,4 dimethyl or 6,6 dimethyl. Which should we do? We should do 4,4 dimethyl. So I'm going to go ahead and erase all the red. And I'm going to keep on numbering counterclockwise so we can see how many carbons we have in our ring there. All right, so if we were to name the parent, what we would have is cyclo what? We would have cycloheptene. We could also write 1 cycloheptene if we wanted to definitely make sure everybody knows that the double bond starts at carbon 1, but we don't need to put it because it's a cyclic structure. And there's only 1 double bond, and we get to number it and blah, 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 blah. Okay, so what we have for our branches are 4-methyl and 4-methyl, which makes 4,4-dimethyl. So putting it all together, we will have, and let me squish it in up here, 4,4-dimethyl, what? 4,4-dimethyl cycloheptene. And again, you could put 4,4-dimethyl 1-cycloheptene or 4,4-dimethyl cyclohept 1-ene. You will see those also. Okay, friends, are we all right with this? If you're not, definitely come to office hours or ask questions in lecture or lab and we can go over more examples. But I think we're okay now, and also I can't hear you, so I'm just going to go ahead and move on to the drawing part, which is always really fun. We always love drawing. All right, so let's go ahead and draw 3-ethyl 2,2-dimethyl 3-heptene. So we've got a 7-carbon chain because we've got hept. So let's go ahead and draw it in line bond form because that's my favorite because you don't have to worry about the hydrogens. I just have to assume you know how many hydrogens are on each carbon when I go to grade your papers. Okay, so remember the first carbon is when your pen hits the paper. Don't wait until you draw the line to count number 1. So it hits the paper or hits the screen and it's 1. So we've got 1, 2, 3, 4. Darn it. Don't do that, technology. Okay. 1, 2, 3, 4, 5, 6, 7. And remember, I could draw this upside down so it looks like an extended W with another V hanging off of it, or I could draw it sideways or diagonal or whatever. All right. So let's go ahead and number the carbons to make sure we've got 7. So we've got 1, 2, 3, 4, 5, 6, 7. Yay, we did that okay. All right, so we've got 3-heptene. So this is saying that we have a double bond between which 2 carbons? Between 3 and 4. So go ahead and draw it in. Now you can draw it on the top of that bond like that, or you can draw it on the bottom. Either way, now that you've drawn that second line there, it means that there is a double bond between these 2 carbons, okay? But don't draw the carbons in because once you draw the carbons in, you're supposed to draw all the hydrogens in, and then that just gets you in trouble. So let's go ahead and take those out. And again, you can draw that double bond on top or on the bottom. Does not matter. Alrighty, so we've got our 3-heptene portion. We got that down. Now we want to do either 3-ethyl or 2,2-dimethyl. So we go ahead and locate one of those carbons. I would go with the 2,2-dimethyl just because I'm the one with the pen, okay? So I can go ahead and erase the number 2 there because I want to. And then I can just draw a couple of sticks. 1, 2. All right. Remember, you can stick a CH3 on the end of those if you'd like, but it's just easier to just draw the sticks. Now, if you mean something other than a CH3, you need to draw it in. So if you've got a bromine or a hydrogen or a chlorine or an ethyl or a propyl or something else on the end there, you have to draw it. Okay, so we've taken care of the 2,2-dimethyl. Now we want to do the 3-ethyl. So let's go ahead and just erase the rest of these numbers here. So nobody grading it gets confused by what you mean. And we'll go ahead and go to carbon number 3, which is right there. And we want to draw an ethyl in. And an ethyl has how many carbons? It has 2. An ethyl group comes from ethane. Ethane is CH3, CH3. Ethyl has a CH3 on the end, but where you connect it to the rest of the molecule, there's just a CH2. So we can draw it a number of different ways. You can draw it like that, or you can draw it like that, or you can draw it like this, or you can draw it like this, or you can draw it like this. Bunch of different ways, my friends, but if we're going to keep with the line bond structure, let's just go ahead excuse me, and draw the line bond structure. So remember, at each of the points and each of the ends, you have a carbon. So there's a carbon there, and there's a carbon there. And again, with the carbon structure, you don't have to remember how many hydrogens each of your carbons have. I just have to assume you know what you're doing. Okay, so there we have our 3-ethyl, 2,2-dimethyl, 3-heptene. Okay, let's draw 2,3,3-trimethyl, 1,4,6 octatriene. So how long is our longest continuous carbon chain? Well, oct right there tells you it's how many? That it's 8. So let's go ahead and draw this. 1, 2, 3, 4, 5, 6, 7, 8. And then the rest of the name, triene, tells you that you've got 3 double bonds. Where are they? They start at carbons 1, 4, and 6. So we just go ahead and draw those in. So between carbons 1 and 2, we've got a double bond. Between carbons 4 and 5, we've got a double bond. Between carbons 6 and 7, we've got a double bond. Okay. And what else do we have on this chain? Well, we've got methyls all over the place. We've got 1 at carbon number 2. So let me go ahead and erase that 2. And go ahead and just put a methyl group right there. We've also got a couple at carbon number 3. So I'm going to erase the 3 there and put a couple of sticks. Like that. So we've got 2 methyl groups. And remember, methyl is CH3. So if you need to see the carbons and the hydrogens there, well, there they are. I drew them in for you. And remember, a CH3 is the same thing as an H3C, my friends. Alrighty. That is the end of this lecture video. In the next one, we'll do cis-trans isomers. Yay! All right, bye-bye.